Welcome, students. Today we are going to look at computational thinking and programming logic. And in this lesson, we will look at algorithms. We will also look at flowcharts, and we will end it with data structures. So let's move through it. What is an algorithm? Now, in our daily lives, almost everything that we are doing, we are following what we call an algorithm. So, for instance, if you want to prepare your favorite food, like banku, what do? You follow some steps in preparing it. So those steps that you follow in preparing it is what we call an algorithm. So let's say you take your corn dough, you go for your cassava dough, and also you go for your water, go for your cooking pot. You mix all of them together in the cooking pot, and you set a fire and put the banku on it. So you stir it, you keep on stirring it, and you also keep on adding water to how soft or hard you want it to be. So you keep stirring it until the banku is boiled. Then you serve it. So the steps that you followed in bringing out the banku or the boiled banku is what we call an algorithm. So it is just a steps that you are following to complete a task. The same thing happens when we are doing programming. So when we talk about algorithm, we are saying that an algorithm is a series of steps that you follow to solve or complete a task. So that is what an algorithm is in simple things. All right. Now let's look at the key characteristics of an algorithm. When we talk about algorithm must have an input. That is the data the user enters to start the process. So in your banku preparation, the things that you brought together before starting the process are what we call the inputs. So you brought corn dough, you brought cassava dough, you brought water, you also added salt. All these things, bringing them together to finish the process or to begin the process, is what we call the input way. Then we also have an output. The output is the result or the solution based on the given input. So when you add corn dough, cassava dough, water, salt, and you put it on fire, boil it, the output that you're getting is banku. That is what we call the output here. Then another characteristic of an algorithm is definiteness. Now, each step must be precise and clear. Each size must be precise and clear. So there should be no ambiguity here. You must explain or you must follow a clear step so that you can achieve the desired goal. Then let's talk about the finiteness. Now, must have a finite number of steps and eventually end. So, you saw that in the banku preparation, you started from somewhere and you also ended somewhere. Yes, that is the finiteness that we are talking about. A program cannot run without ending. So when there is an algorithm or when you are writing an algorithm, it should have a start and also it should also end. So that is the finiteness that we are talking about here. Then also effectiveness. Now this step should be simple and executable. So it should be something simple, and also when running it, it should be able to run. All right. So when you get your banku, the banku should taste like banku. It shouldn't taste like fufu. That is it. That is the effectiveness that we are talking about here. Then it should be language independence. It should be language when you are writing an algorithm for a program. It should be language independent. That means it should be able to implement it in any programming language. You can use any programming language to run that algorithm that you've written. So as we move on, you look at one of them, then you understand it better. Let's look at types of algorithm. When we're talking about algorithm, when we're talking about step-by-step instructions of doing something, then sorting, we have what we call sorting algorithm. That is arranging elements in order. That is alphabetical order or something. So somebody can give you a task that, okay, do you have a scrambled letters that you have to arrange them? So you have to know each position each of them will be. So in doing that, you are performing an algorithm. So sorting is also a form of algorithm. Then you can also talk about mathematical algorithm, that is performing calculations. So when you are performing calculation, you are also performing an algorithm. So if I tell you to add two numbers, first you say, okay, which number should I add? So you go for the two numbers, you add them, you process it, and you get the outcome that you want. So in doing so, you're also performing algorithm. Then we also have encryption algorithm, which encode data for security. Then we have search algorithm, that is finding elements in the data. So these are all types of algorithms that we have, but we look at them in details later, or as we even move on, you get to understand these ones. All right, so let's give a real life example of an algorithm. So, an algorithm for a child getting ready for school. So, you're a child that you are getting ready for school. What is the algorithm that you follow? One, you wake up. Then two, you brush your teeth. Three, you wash down or you go and bath. Four, you dress. Five, you eat your breakfast. You get your school bag, then you travel to school. This is an algorithm. This is an algorithm. You are following a steps in getting ready for school. All right, so let's move on. Let's look at the visual representation of an algorithm process. So let me zoom this so that you can all see it. So this is a problem and we are going to use an algorithm to solve it. So one, that is find the sum of 529 and 256, which means you are going to add 529 and 256 together. Now, in doing so, you are performing what we call an algorithm. So let's look at the inputs. The 529 and the 256, these two values are what we call an input. Okay, so first of all, this is the algorithm that we're going to follow. These are the step-by-step instructions that we are going to follow. So one, you assign, please note this, you assign X to 529. Then two, you assign Y to 256. Then three, you calculate. So you assign Z for the answer. That is this plus this should give you the Z. So now Z is equal to X plus Y plus, X plus Y. That will give you the Z. So our output will be the Z. So as we move on, you understand why X, Y, and Z. But in your layman's view, you are adding this and this, and you are getting result as X plus Y, or 2 or 5 to 9 plus 2, 5, 6, and you are getting what we have as 785. Sure. 785. So step one, this is what you are going to do. Then step two is you getting the solution. All right. So these are our inputs, this and that. That is what we added to get these outputs. And this is the outputs. And when we talk about the definiteness, that is, we have the clear steps that we followed to get the result. And also, we have the finite, as we are talking about, the steps that we used to get to the result. It's what we call the finiteness. And lastly, we have the effectiveness, that is the simple operation that we did to get to the result. All right, let's move on. Let's move on with one simple example in mathematics. So the same problem, you are doing the same problem in Python code. So let's see how we do that. Now we are going to use what we call pseudocode. Now when we talk about pseudocode, it's just like me telling you the process of solving a problem. That's what we call a pseudocode. It's just explaining the steps in a simple language, in an English language that everyone will understand it. So this is the problem. Find the sum of 529 and 256. The way you are going to tell someone how to get the answer is what we call the pseudocode. You are not writing code, you are just using normal English language to explain how you're going to achieve the answer. So that is what we call the pseudocode. So the first one is assign x to the value 529. When we say assign x, it's just like let x is equal to 529. That is it. Then the second one is assign y to the value 256. So we assign y to the value 256. Then third step, assign z to the sum of x and y. That is, when you add x and y, you give the value to z. And that is what we have here. X is equal to x plus y. Then we get the output for the value of z. So we print z and we are going to get the result. So I'm going to demonstrate this to you. So this is our Python console and I'm going to show you how it works. And the first one is assign x the value 529. So x is equal to 529. All right. Now, what is y? Y should be equal to 256. Now, what is z? Z is equal to the x plus the y. So what we are going to do is we are going to look for the result for z. So we print z. We print z. So when you say print in a Python code, it means let's display the answer for us. So if I press enter, I should get the result for the sum of the x and the y. So I'm getting 785 as the answer. As you know that 785 is the answer. So this is the output that we have here. Now I know that most of you don't understand why x, y, and z. So this brings us to what we call variables. What we call variables. Now when we talk about variables, they are named storage locations that hold a value or an object which can be changed. So they are saying it's a named storage location that hold a value. So X is a storage location and it is holding the value of this. Y is also storage location which is also holding the value of 256. So that is why when we added X and Y, we were able to get these values because X is holding this and Y is also holding that. So think of a variable as a labeled box that stores information in your program. So assuming this is a box, the box contains this, and this is also another box which contains this value. So Z is a big box that all these two boxes are inside. So when you add the values of those two boxes, now the bigger box, which is Z, should give us the output of what we have in X and Y. I think this is understandable. All right, let's see some key points about variables. Now, when we talk about variables, variables have names or what we call identifiers. Example, a variable can be X, it can be Y, it can be total, it can be name. That is it. So let's look at one example here. If I say I can declare a variable like, let's say name, then I'll give it a value like, let's say Aman. And I can declare another one as school. And I will give it a value as, let's say, mass. Okay. Now I can declare another one as total. Total. All right. And I'll give it the value of name plus school. Okay. So if I print total, I know what you are thinking. If I print total, I should get what we call AMA bus. Yes. So if I print total, now I'm getting AMA bus. Why so? Because this is a variable which is holding AMA, and school is also a variable holding bus. And I've said it, I have declared it here that my total should be, or my bigger box should contain name and school. So if I want to see what is in my bigger box, then the bigger box should show AMA then bus. That is it. So that is how variables are. So you can also declare variable stores values. Yes, variables they stores values. That is why this one, this is a variable. It is storing AMA. This is also a variable. This storing. So please, variables they are not something like which is there that you must always go for. You can declare the variable yourself. Whatever that you want to call the variable is up to you. So you are going to declare a variable for yourself. For instance, I can have a variable like first name, then I'll give it, let's say, Kojo. Kojo. All right, as my first name. Then I can declare surname as Mesa. As Mesa. All right. So, sorry, I think I have an issue error. All right. First name as Kojo, then my surname as Mason. All right, this. Okay. Now I can have full name. Full name should equal to first name plus surname. Okay. So if I print full name, I should get Kojo Mensa. That is it. So variable, you have to declare it yourself, and a variable must hold a value. Okay. A variable stores value. That is it. So variable, they stores value like this one, like hello, like this also. Okay. Variables values can be changed during program execution. Yes. The values, you can change them during the program execution. Okay. In Python, lowercase letters for variable names. All right. Let's move on. Now we have this symbol here that we all know that it is called equal to. But when we come to programming, we call it assignment operator. We call this assignment operator. Now this is an example. So we assign 16 to 8 to what we call variable age. We assign true to what we call reply. We assign this to this. We assign Kumasi to city. We assign PlayStation to this one. So that symbol that we have here is what we call assign or assignment operator. It is not called equal to. So please don't go and say age is equal to 16. No. Let's see how this works in our Python console. So let's say I assign 16 to A, then I will assign, let's say 10 to B. Then I'll assign C to A. Now note this. When I print C, you should get 16. Why? Because I'm assigning A to C, whereby A is 16, or I've assigned 16 to A. That's how it works. So let me ask, is C equal to A? That's the question that I'll ask. Is C equal to A? Yes, C is equal to A. So we see that we are getting true. So we are using this that we call equal or comparison operator to compare and see if that is it. Now, is C equal to B? Is C equal to B? No, because we haven't assigned C to B, so C is not equal to B. So we will get false for that. Let me try one last thing. Is C equal to 16? Let's see. Yes, C is equal to 16. And is A equal to 16? Yes, A is equal to 16. So that is how the assignment operator works. And also the equal sign, the equal to, also works in programming. Okay, so let's move on. Now that we know the assignment operator and the equal symbol, let's move on with using variables in programming. So this is a variable message, and the message is Python is fun. So if you print message, what you expect to show is this one, Python is fun. Now we have another variable which is information, and it is assigned to this message. My message to you is that. Now if I print information plus message, then I must get an output like my message to you is Python is fun. And I've done some already that you know how it works. I can still, let me see if I can copy this and put on our console, then see if you get that result. Okay. Yes, as I said, you can see that the result here is my message to you is Python is fun. And the first one, what you got is Python is fun. For the message, as we have the message Python is fun, and we have the information this. You can also do one thing. You can say all. So all messages should equal to message plus information. So if I print all, if I print all, I should get this same message. My message to you is Python is fun, because I am just bringing these ones together in a one big container or one big box. That is how it works when we are doing programming. So please, if you want to know how to program well, then your variables, please know how you can use variables, how you can declare variables, how you can assign them to a value. All right, let's move on to what we call the flowchart. Then we see what's next. Now, when we talk about flowchart, it is just a graphical representation of algorithms that uses shapes and arrow to illustrate the sequence of steps in an algorithm. While pseudocode uses plain text to show steps, flowchart uses shapes to solve the same problem. So let's look at the basic symbols in flowchart. Now we have oval. That is, the name is terminator. What do we use it for? It shows where a process begins or it ends. Then we have the rectangle, which is called processing. It shows action or operations. It does the calculations, it does the assignment and the rest. Then we also have the parallelogram, which also symbolizes input and output. It shows data being entered and also data being displayed. Then we also have the diamond symbol that we use it for decision making. So it shows a choice or condition with different outcome. Alright. Then we also have the arrows, that is our flow lines, shows the order of instructions and connections. Then we have the circle, one-page connector. It links different parts on the same page. Then we have pentagon, of which, so these two, we will not talk about it now. We will look at these 1, 2, 3, 4, and 5, these 5 symbols that we look at for now. So there is the terminator symbol, there is the processing symbol, there is the input and output symbol, there is the decision making symbol, there is the flow line, there is the on-page connector, there is off-page connector. Alright, so the oval marks the beginning and the end point, rectangle shows the calculation or the action, parallelogram are for user input and output, diamond represents yes or no decision, arrow shows the direction of program flow, and we also have the connectors which links different parts of flowchart together. So let's look at the same example that we're having up there. Now, the summing of the two variables or summing of two numbers. If you want to sum two numbers, I want to add this and that. Now, what you do is the first thing is you start. So you draw your start. Then the next one is you assign this 529 to x. Then the next step, this is input. Look at the symbol. This is the input symbol. If you come up there, this is the input or the output symbol. Alright. So you assign y. You assign 256 to y. Now, this is the processing symbol. So this is where the calculation will take place. So z is equal to x plus y. So if you calculate this, then you can say that x plus y has been assigned to z. So z is going to do the computation for us. And we are going to see what z have for us, which is this one. So you can see that the output will be shown here. After that, we end the flow. That is how we solve a problem using the flow chart. So we look at more at the end. Alright. So the oval starts, the rectangle processes, the parallelogram also inputs and output operation. Then the arrow shows the flow line. Why do we use flowcharts? Why do we use flowchart? Now, flowchart is a visual and easy to understand. The visual and easy to understand. So, as you can see, this is a flowchart. You can see that this is an input, this is an input. This one is just doing the processing. This one is giving us the output, the start and the end. So, it is very easy to understand. It shows the logic flow and also makes things very clear. Now, it is a great tool for planning before coding and also helps to identify error in our logics. So that is the flowchart that I have for you. Yeah, maybe I'll drop a video or another video on how some of these, the flowchart works in solving problems. Let's move on to what we call data structures. All right. Continue with the data structures. Now, what is a data structure? Or what are data structures? Now, data structures are used to organize and store collection of data in a way that makes it easy to access and modify. So if you gather a data, then the data structures are just going to allow you to organize and store them in a very simple way that you can easily use or retrieve them for your work. So they are like building blocks that allow programmers to efficiently store, retrieve, and manipulate data in their computer programs. So that is it. It's very simple. So data structure is a way of organizing data so that it can efficiently be used in our program. All right. Now, importance of data structures. 1, it helps to organize and store data efficiently. It also enables efficient storage and retrieval of data. It also reduces processing time and improves performance. It is essential for becoming a programmer, and they also allow you to write more efficient code. So these are the importance of data structures. Now, data structures has been classified into two. We have linear and also we have the non-linear. Let's look at the linear data structure. When we talk about linear data structure, we say that data elements are arranged in a sequential or end-to-end manner. Each element has a predecessor and successors except the first and the last. So that is the linear data structure. Let me see if I'll have an image to show you. All right. So this is a linear data structure. So everything is in sequential order. So item 1, item 2, item 3, item 4. So the elements are in sequence. One path from start to end. Easy to traverse, or easy to, when you say traverse, that's move from one to another, okay? Then simple implementation. So that is the linear structure that we have here. So the data elements are arranged in a sequential order. That is it. So it's just like drawing our sets. The set table that we have, let's say 1, 2, 3, 4, 5, 6, 7, or even bringing a set and bringing name of shapes in it. So that is still you are doing what? Data structures. Now, what are the characteristics? Now, items are related to previous and the next item. All right. Data is arranged in linear sequence and can be retrieved or can be traversed in a single run. Implementation is very easy. So examples are arrays, stacks, queues, then linked lists. So in real life example, people waiting in a queue at a bank or a market is an example of linear data structure. That is it. So you know that from this person, you are moving to the next person. Even as when sometimes you are coming to write exams, you arrange yourself in a queue so that you know that, okay, from this person, I'll be the next person. So that is the linear data structure. Data is organized in a sequential order or in a linear sequence form. That is it. Then we also have one which is non-linear. Data elements are not organized sequentially but in an interconnected manner. They are all linked together, but they are not arranged in a sequential order like the linear. Yeah, so this is the non-linear. So from this, you come to this one, you move here, you move here. So you can see that here, this one doesn't have direct link with these ones. All right, that is it. But they all have the same root. So this is the non-linear data structure. All right. Non-linear, okay, the elements are not organized sequentially, but in an interconnected manner. So these are the characteristics. 1, every item is attached to many other items. Every item is attached to many other items. So this one is attached to many. So this one can move from here, come here, and come here. This one also can go here, can come here. This one can move here, it can also go here. This one can move to this side, it can come to this side, or can come to this side. So that is the many other items. All right. Now, data is not arranged in sequence, as we know. Now, we cannot traverse in a single run. You cannot move from 1 to 2 to 3. No. You can either go to the left or you can move to the right. So data is not, you cannot traverse or you cannot move through data from in a one line. You can either go to the left side or the right side, or even go to the first one, then come back to the second one. So that is the nonlinear sequence structure. Then implementation is very difficult. It is not easy to implement it. Then it may be faster access time. It may have faster access time, but require more memory. All right. So that is it. So we have examples like trees, then graphs. So like organizational hierarchy, then we also have like social media connections. So in real life example, school administration hierarchy, we have the headmistress. From headmistress, you go to assistant heads, then you come to the departmental heads, then you go to the rest. So that is how the non-linear data structures is, or that is how it works. Now let's see the comparison that we have here. Now let's see the data arrangement for linear and the non-linear. Now the data arrangements with the linear, data is arranged in a sequential order. That means from one to another, that or one after another. But with the nonlinear, data is arranged in a hierarchical order or in an interconnected manner. Let's see the links. Now this one, each item is linked to the next or the previous one. So if you look at it from here, now this one is linked to this one. This one is linked to this one. This one is linked to this one. This one is also linked to this one. This is linked. So it is either linking to the next or the previous one. That is how the links work. That is how the linear has been linked. But with this one, each item is linked to many items. Each item is linked to many items. As we saw here, this one is linked to this one, also linked to this one. So it's not linked to only one. This one is also linked to this one, also linked to this one. It's not linked to only one. So each item is linked to many items. All right. Traversing or moving through the data. Now this one, it moves in just a single manner or single run. But this one, it moves in the multiple paths. So this, it is just moving. If you want to look for item 3, you move from here to this one, then you reach item 3. But in this one, if you want to look for this one, then you have to come here, check here. If you don't find it, you check here. If you don't find it, you have to come back, pass here, check here, move to this side. If you don't find it, come back and check. So in finding data, it will be very difficult in finding data. But this one, you just move in one direction, then you find what you are looking for. So this have the nonlinear, it has multiple paths, but the linear has a just single path. The implementation, this one is very easy to implement. The linear is very easy to implement, but the nonlinear, it is very difficult to implement. The examples are, you have arrays, stacks, queues. We also look at that later. Then with this one, we have the tree, the graph, and the rest. So that is the image. These are the images representing the linear and the non-linear. All right. Now we also have other classifications that we have in data structures. We have dynamic and static data structures. Now with the static data structures, we have one, these are the characteristics. It has a fixed size. It has a fixed size. Memory allocated at a compile time. Memory is allocated at a compile time. Then the size cannot be changed after compilation. Then examples are arrays. Then we have the dynamic data structures. Then it also has a size that can be changed, memory allocated at runtime, can grow or shrink as needed. Example is a linked list. All right. Now let's look at arrays. Now array is a linear data structure. What is it? Let's look at arrays. Now when we talk about arrays, we are talking about an array is a collection of elements stored in the contiguous memory locations. Each element can be accessed by its index. All right. Think of it like a market list where you neatly arrange items. So you have akala, we have fufu, kenke, banku, then we have red in rows. Now making it easy to find, add, or swap items. So when you arrange these items in this form, it makes it very easy for you to get to an item or reach an item. So that is that. Let's look at this, how arrays works. So this is the first item, this is the second item, this is the third item, fourth, and the fifth. But with arrays, we use what we call index. So the position of an item is where we call the index. And when we are counting in an array, we start from 0. We don't start from 1. So array indexes always start from 0 and not 1. Array uses zero-based indexing, meaning the first element in an index, the first element is at index 0. All right. So this one is at index 0. The next one, 1, 2, 3, 4. So if we are finding for item at index 2, then we are talking about kinky. We are not talking about fufu. We are talking about kinky. That is where the index is. So if I want item at index 1, then I'm talking about fufu, not apple. I don't know if you understand it. Yeah. So even though we have 5 items here, in arrays, we still count from 0. Then we move on to the last item. All right. Let's move on. So in Python, this is how it works. All right. We have foods. And it has been arranged in an array form. Okay. So this one is a square bracket, which representing that what we have, the data we have is the data we have is in an array form. So we have apene, we have fufu, we have kenke, we have banku. Now, if I want to access the food at 0, at index 0, then it should be this one. Food at index 2, it should be kinky. All right, so let's see. Let me copy this and remove it to our console to see if it is true. Okay, so I want food at food at index of 0, 1, 2, 3. Food at index 3. Then I must get banku. That is it. Food at index 0. I must get the first food. That is how arrays works. All right. Now let's look at the operations of an array. Now we have reverse. We have the reverse. Reverse the order of an element. 1, we can reverse order of an element. We can let the first one become the last. We can let the last become the first. We can also sort elements in an order. We can also find specific element. We can count number of occurrences of an element. We can also duplicate the array. So this one, we can manipulate it in any form that we want. We can sort them, we can count them, we can rearrange them, we can reverse them. So depending on how you want to manipulate the data. All right, let's look at reversing an array. Okay, we have this activity. This is a variable, and it has been assigned to this array. Morning jog, we have breakfast, we have study. Now, you print the original activities, and you are going to, after that, you reverse all the activities. So let's copy them and put them in our console and see how it works. Then put them in our console to see how it works. Okay. So you can see that this one, because we have the reverse of our activity, you can see study first, breakfast, and morning jog as the last one here. So instead of arranging in this order, it has been arranged in the reverse order. Okay, so the same output that we are getting here. All right, okay. Now we also have counting occurrences, the number of times an object or an item occurs in a certain array. So if you take this array, for instance, we have tablets, we have desktop, tablets, smartphones, supercomputer, tablet. So if you want to know the number of times the tablet is appearing, that is the number of occurrences that we are talking about, then we assign this one to this one to this. Okay, so when we are printing, we print the number of, to check one, the number of tablets is what? So we count the computer list here, then we bring this one to show the number of tablets that we have here. So if I copy everything to our console, we are going to see it in action. Okay. All right. So when we print this one, the number of, to check one is tablets. So the number of tablets that we have in this list is 3, or R3, 1, 2, 3. So we have 3 tablets in the array. And when we are looking at mainframe, at least we don't have mainframe here. So therefore, when we print mainframe, we are not going to get mainframe computers. Now, let me print. How many desktops do we have here? Okay, we don't have any desktop. We have only one desktop here. So we can also do to check. Let me use the same type of, to check 3. Okay. Desktop. Okay. All right. Now, if I have to print number of desktop into check 3, then I will change this variable to check 3 because we have used to check 3 as our desktop. So if you print, we will see that we only have one desktop. So let me change this one so that number of to check 3. All right. So the number of desktop is what? Is 1. So that is how it works. Okay, so this is the output of what we are getting. Let's look at the final one, which is the 3 algorithm representations, and I think we will end it. All right. All right, the same algorithm can be represented in 3 different ways. 1, we have the pseudocode. 2, we have the flowchart, and the 3, the programming itself. So pseudocode, we write them or we say them in the simple English form. It is also best for planning and communicating, as I've done here. Advantage, language independence, then easy to understand. Then flowchart uses a visual diagram with shapes and arrows to show the flow of a program or how a process is done. All right, then we have the programming itself. The programming is the actual programming that we do, like in the Python code. The computer executes it, then we can run it can be run by the computer and produce the actual result. So as we did in the Python console. All right, so let's look at the swap algorithm. With the swap algorithm, it is like you have 3 items. You have 2 boxes that you want. Okay, let me use what I have here. I have cup A, which has water in it, and cup B, which has juice in it. I want the water to be in cup B and the juice to also be in cup A. Now you see that this is a bit impossible. So what you're going to do is you are going to introduce what you call a temporal variable, a temp variable. You are going to bring extra cup that you pour one juice, you pour one of the items in it before you can do the swapping. So let's look at it from this angle. So this is the first cup, it has a water. This is the second cup, it has a juice. So we bring what we call a temporal cup. This is not part of our cups, but we just bring it so that it will help us to do the swapping. So we're going to pour the water into this temporal cup so that the first cup will be empty. Then we pour the juice to the first cup as we have here, so that the second cup will be empty. Then finally, we pour the water into the second cup and we are going to get this. So that is the swap algorithm that we have. It is very simple and easy. Okay. Let me go back to the Python code that we have here, then explain it to you. Now, this is a temporal and it is called to A. It has been assigned to A. So it stores the first value in a temporal variable. Now we say A is equal to B, or we assign A to B to copy the value of the first variable. Then finally B will be assigned to temporal. Then we copy the temporal variable to it, then we swap. So let's look at this from here. 49 has been assigned to A and 61 has been assigned to B. Now we want 61 to be assigned to A whilst 49 being assigned to B. What do we do? That's where we introduce what we call a temporal variable. We assign A to the temporal, which means we are just giving 49 to A. Then we put what is in B to A. So B will be assigned to A. Now, finally, we take what the A has given to them and give it to B. After that, the swap has been done successfully. So if I copy this code, we will see that everything will be changed successfully. Let me paste. Now you can see that after the swap, A is having 61 and B is having 49. That is how it works. Okay, so this is the swap that we did. So why do we use a temporal variable? Without a temporal variable, we will lose the original value of A when using or when assigning B to it, which means we have to pour this away. So if you don't introduce temporal variable, which means if this one is not there, which means you have to pour this one away before we can put the water into this cup, which means we are going to waste the juice. So that is why we need a temporal variable in order for us to complete a task like that. So these are the summary of whatever that we've done. And we have done variables, we've done algorithm, flowcharts, data structures, linear, nonlinear swap, and the 3 representations of the data. If you have any question concerning what you've done so far, you can also share it on the WhatsApp page so that I will clarify things for you. Thank you very much for your time.